Standard form of complex number. What is standard form of complex number? A plus B, where real part of the Z is A and imaginary part of the Z is B. I नहीं, हाँ B. I include नहीं करते, right? Now second quantity which we need is modulus, under root of real part square plus imaginary part square, and argument tan inverse of imaginary part upon real part. આ થોડી basic information હતી જેની આપણને જરૂર હોય mostly. Then higher power of I is actually under root of -1, right? So I square must be -1. Then what about I cube? It is actually product of I square and I square is nothing but -1, so this will become -I. Similarly, I raised to 4 is product of I square and I square. -1 becomes 1. Okay. Similarly, if you want to find out power of I raised to 5, then split into I raised to 4 and I raised to 1. I raised to 4 is 1, I ones are I. In case of I raised to 6, 4 and 2, so that will be -I. I raised to 7, I raised to 4 into I raised to 3. I raised to 4 is 1, I cube is -I. Sorry, I -1 also. Then I raised to 8, product of I raised to 4 and I raised to 4, that will be 1. So notice करें तुम्हारी values repeat થાય. I -1 minus I 1. Again I -1 minus I and 1. Right? તો તમે I ના power increase કરો તો એની value increase થતી નથી. Right? એની value શું થાય? Repeat થાય. So if you want to obtain I raised to 109, so in technique याद से શું કરતા હતા? Yes, divided by 4. We simply divide 109 by 4. 4 2s are 8. Then 4 7s are 28. Remainder is 1. So I raised to 109 is simply I raised to 1. Got it? No problem. Ekdam easy peasy. Okay. Now let's try to solve your exercise. Starting में આપણે થોડા easy questions કરીશું, પછી થોડા hard કરતા જઈશું. Okay? First question, easiest one. એક નાનકડી બીજી વસ્તુ. તો તમને યાદ હોવી જોઈએ, but still. What is 1 upon I? Yes, very good. Pandeyji has a formula. We have to multiply and divide by minus I. Right? So minus I ones are, and in denominator will get minus I square, where I square is so this will become minus I. Right? So just remember 1 upon I is minus I. Done? Okay. Now let's use this information. Okay. What we have? Here we have n as a positive integer, and we have to find value of 1 minus I raised to n and 1 minus 1 upon I raised to n. So we have to simplify this. Take whole raised to n common. First term will be 1 minus I and second term will be 1 minus 1 upon I. Now 1 upon I ગમે તમને જરા શું કરવાનું? Yes, 1 upon I is simply minus I. So this will become 1 plus I. Right? Now here we get a minus b into a plus b. So its product must be a square minus b square. So within the bracket, it will become 1 square minus I square. And we know that the value of I square is minus 1. So this will become 1 plus 1, or we can say 2 raised to n is your answer. Ta-da! एकदम easy. Next पर जाइए. थोड़ा मस्त क्वेश्चन है. देखावा एकदम खतरनाक है. What we have? We have to evaluate summation from n equal to 1 to 13. And we have I raised to n plus I raised to n plus 1. સમેશન કરીએ પહેલા થોડું એક્સપાન્શન કરી દઈએ. કોમન સેન્સ કરી બંને માંથી I raised to n. So remaining term 1 plus I. Okay. Now 1 plus I is actually constant. Take it outside. We just have to expand I raised to n. Place the value of n. Start from 1, 2, 3 up to 30. Okay. I raised to 1, I square, I cube, I raised to 4. कहाँ સુધી આ ચાલશે આ બધું? 13 સુધી, right? Okay. એક નાનકડી વસ્તુ નોટિસ કરો તો. What is the value of I square? Minus 1. And I raised to 4. So both can be cancelled out. Similarly, what is I cube? Minus I. And here we have plus I. So we can say summation of i's from 1 to 4 terms will be 0. Okay, sir, 4 શું કરવા? 5 to 8 નો summation બી શું હશે? Yes, exactly. Up to 12 terms. So આપશે આપણને 0. So the only remaining term will be I raised to 13. Last term છે 12 સુધીનું પેપર 0. Okay. Now what is I raised to 13? 13 divided by 4. Remainder will be 1. So here we get I raised to 1. Now open the bracket. I1 is I is I square. So this will become I square बोले तो minus 1 plus I as your required complex. Right? अब एक नानकड़ो डाउट पूछ लो निष्ठा ने. निष्ठा, real part of the z is and imaginary part of z is બરાબર જ નહીં જણાય. હમણાં જ તું I એ પહેલા મેં કીધું કે I is not part of imaginary. 1. ध्यान રાખજો, ભૂલ થશે આવી. Done? Easy peasy. Another easy question. Actually આવો તમે જોયેલો બી હશે, દેખેલા લાગે ટાઈપ. If x plus iy is equal to 1 plus I upon 1 minus id whole cube minus 1 minus I upon 1 plus id whole cube. હવે કહેશે કે બ્રેકેટ કેમ આમ ખાંચી નાખીશ? આળસુ છું એટલે યસ. બોલતો ભવ્ય, પહેલા બ્રેકેટને સિમ્પ્લિફાય કરવા શું કરીશું? રેશનલાઇઝ. મલ્ટીપ્લાય એન્ડ ડિવાઇડ બાય ઇટ્સ કોણ? યાદ રાખજો હંમેશા. ઓકે. એન્ડ denominator no conjugate is 1 plus. Okay. So let's simplify. In numerator we have 1 plus id whole square. So expand it 1 plus 2i plus I square. And in denominator we have a minus b into a plus b. So we can say 1 square minus I square the whole square. Right? Okay. બોલતો બેટા, સેકન્ડ ટર્મમાં સેમ વસ્તુ કરવાની છે. શું કરીશું? બોલો તો શું મલ્ટીપ્લાય ડિવાઇડ કરીએ? 1 minus I. Very good. So in numerator we'll get 1 minus id whole square. So that will be 1 square minus 2y plus, very good. And in denominator, the whole cube, right? Okay. Now in further simplification, notice that I square is minus 1, so 1 minus 1 will become 0. The only remaining term in numerator is 2y. And what about denominator? Okay. Hold it up. Second bracket ma 1 and I square will be cancelled out. So we'll get minus 2y upon ma as usual 2. The whole cube. So 2 will cancel out. I cube is minus I. And again 2 will cancel out, plus I cube. And that is minus. So here we get a question yaad chhe na. We have to find out x and y. X is actually real part of the left hand side. So by comparing real part, we'll get x equal to, because here we don't have any real part, so we'll consider as 0. And similarly, imaginary part will be y will be minus. Yeah? So ta-da! Question matching. If this condition is given, we have to find value of where, what is your x? Real part of right hand side. And y? So we have to simplify our left hand side first. And for that, numerator simplify करिए. So let's open your numerator. What we have in numerator? 1 plus I square. Open the bracket, we get 1 plus 2y plus I square. Temporary. Okay. And in denominator we have 2 minus I. Okay. Now, what else to करिए बेटा? 1 and I square cancel out. So only remaining term in numerator is, okay. Okay. Now what? Very good. And multiply and divide by conjugate of denominator, which is 2 plus I. चलो multiply करो. 2y 2 जा 4i 2i square upon 4 minus I square. Okay, now simplify. What is 2i square? Minus 2. And 4i will be as it is. And in denominator we have 4 plus 1, or we can say 5. Okay. So we get x plus iy is equal to minus 2 by 5 and 4 by 5. Now, to get the value of x, compare real part, will give us x equal to minus 2 by 5. And by comparing imaginary part, we will get y equal to 4 by 5. So we can say your x plus y must be minus 2 by 5 plus 4 by 5. We can say 2 by 5. Ta-da! Got it? Any problem? Okay. Alright, Nanaknote twist. Suppose we have to find out x square plus y square. In that case, एक modulus on both sides. Modulus के अंदर under root भी आवा. So to avoid that, let's square on x both sides. Let's talk about left hand side. Real part is x square plus imaginary part is y square. I square y square. Okay. Now numerator 1 plus I square. Real part is 1 square plus imaginary part is I square नहीं है, बची गया, फरीकी बची गया. And this whole square yellow वालों as it is. And what about denominator? 2 સ્ક્વેર બરાબર નહીં કરાય 2 સ્ક્વેર પ્લસ માઇનસ 1 સ્ક્વેર આ બહુ જ કોમન મિસ્ટેક છે જે થાય છે પહેલી આઈ વાળી એ તો મેં દંડો મારી ભગાડી દીધી બટ હજુ એક આ રહી ગઈ છે કે ભાઈ વચ્ચે પ્લસ માઇનસ ગમે તે હોય વચ્ચે તો શું જ આવશે પ્લસ ઓકે so we will get x square plus y square is equal to 4 by 5 ta-da nobody kidding question number 5 we have to find a and b it is given that a plus bi is equal to 1 minus I upon 1 plus I raised to 100 okay ये तो देखिला लग रहा है हमरा लेफ्ट साइड में करी राइट what we'll do multiply and divide by its conjugate so it will become minus I raised to 100 minus I raised to 100 means I raised to 100 or we can say 1 so by comparing real parts we will get a equal to 1 and b equal to 0 जो एक नानकड़ी सलाह है याद ज राखी लेजो 1 plus I upon 1 minus I is always I ऊपर जे साइन હોય ને એ જ પાઈ ની સાઇન હશે 1 minus I upon 1 plus I is always minus MCQ માં કામમાં લાગશે જે પણ એક્ઝામ હોય તો સેટ્સ કરવા